Hi, I had a question from one of my students who had a question about this problem using the definition of a derivative to find the equation of the tangent line of the function at f of x equals x with x value equals 2, equals 1, comma, x equals 4. So we first start with the definition of a derivative, f prime of x. F prime of x is how we say the derivative. This means this defined as, that's the definition, it's the limit at h approaches 0 of f of x plus h minus f of x all over h. And that's the definition of a derivative for any function. There's two other different definitions of derivatives, but we'll be using this one right over here. So the first thing we have to do is we have to find f of x plus h using this function right here. So I'm going to underline it red right there. Since f of x equals the square root of x, f of x plus h, we stuff x plus h where there's x. So we stuff it in here, and it's just going to be x plus h. Okay? So what do? I used purple last time, so we'll keep it at purple. F prime of x is equal to the limit at h approaches 0. F of x plus h is right over there. The square root of x plus h minus f of x, right there, square root of x all over h. Okay? So, what's going on? We have to manipulate this portion a little bit. I have to multiply this by what is called the conjugate. That's the key. I multiply the top and bottom by the square root of x plus h plus the square root of x. And we do the same thing with the denominator, x plus h plus the square root of x. So a conjugate is the same thing as this, except with the minus is a plus. If this was a plus, you multiply the conjugate, which just turns into a minus. Okay? And so we're going to forward this out. Let's keep it up a little bit. F prime of x is equal to the limit as h approaches 0. Now, what's the beauty of conjugates here is square root of x plus h times the square root of x plus h. The square root of the squared, it just becomes x plus h. The outer and the inner will always cancel in conjugate. This of the outer portion and the inner portion, one's going to be a plus, one's going to be a minus. So you notice, because this is the minus, it's going to cancel it out. And then L, square root of x times square root of x is minus x. All over. We do not multiply the denominator, keep it factored. H times the square root of x plus h plus the square root of x. What do we notice? A lot of things are going to cancel in the numerator. Okay, and so I'm going to use a highlighter. Where's my highlighter? There it is, right there. The x and the minus x is going to cancel. So you end up with just h right over there. This h better cancel with the numerator and the denominator as well. If it doesn't, then you're kind of screwed, which means that you probably did something wrong. So you have to cancel. It becomes a 1. So now, let's rewrite it really nice and neat with purple. I used purple last time. F prime of x, which is the derivative, equal to the limit as h approaches 0 of 1 over square root of x plus h plus the square root of x. Now you can plug in 0 for h right there. X plus 0 is x, then end with 1 over square root of x plus the square root of x. What's the square root of x plus square root of x? It's 1 over, you have 2 square root of x. That's f prime of x. That's the derivative. Another word for derivative is the tangential slope. Tangential slope function. Okay? Don't forget, f prime of x, tangential slope function, it means the same thing, it's synonymous. Okay? Right now. You end up with 1 over 2 root x. Now at x equals 1, I'm going to use this right over here. At x equals 1, f prime of 1, slope at the point 1 is 1 over 2 times the square root of 1. You plug in 1 in here, and it becomes 1 half. The slope, we use m for slope, equals 1 half. Now, when we plug in 1 into your original function, what do you get for your y value? Well, the square root of 1 is just 1. I'm going to use red. No. The y value is 1. Using the point and the slope, you have a point slope form, which is y minus y1 is equal to m times x minus x1. Put this aside right over there. And so here's your point. Right there, and that's your slope. So plug in this one in blue goes in here, and this lime green goes in here right there. Okay. And so plug it in, we get y minus 1 is equal to 1 half times x minus 1. There's your point slope form. You can change it to slope intercept form, doesn't really matter. Let's try x equals 4 now. When x equals 4, we plug in 4 in here. What's the square root of 4? It's going to be 2, right? At 4 comma 2. I'm going to put that, so you put the same thing in here. You end up with, let's use purple, y minus 2, I'm going to use red ink for that, is equal to, and xm, which is the slope. I have to plug in slope in here. So what's the square root of 4? Square root of 4, f prime of 4 is equal to 1 over 2 root 4. Root 4 is 2. 2 times 2 is 4, so it's going to be 1/4. 1/4 times x minus 4. I'm going to show you an easy way to find the slope using what's called a power rule. It's a little bit of a cheating method, so let's use the cheating method. You're going to have to know how to use what's called a power rule anyway. P-O-W-E-R rule. If f of x is equal to x to the n, then f prime of x, you bring down the power, bring it all down, the southern draw, n, and then you subtract 1, x to the n minus 1. This is called the power rule. So let's do an example. Y equals 2x cubed, y prime, the derivative, bring it all down, so it's 2 times 3 times x to the, subtract 1 on that, you clean it up, 2 times 3 is 6, x to the 3 minus 1 is 2, that's your derivative. Well, let's try to use that for our previous example, y equals square root of x, or you can call, instead of calling it y, you can call it f of x. First thing we need to do is change this to an exponential state instead of a radical state. Same thing as x to the 1/2 power. If you remember, from radical state to exponential state, you take the derivative now, bring it all down. This is 1/2 times x to the, what's 1/2 minus 1? Negative 1/2. Right? How do you get rid of the negative? It's 1 over 2 times x to the 1/2. What's x to the 1/2 in the denominator? 1 over 2 radical x. So going from an radical state to an exponential state, using the power rule, we get the derivative, and then we simplify it from a negative exponent to down here, and then we go from exponential state to a radical state again. Let's together. Look at the definition right here. So we use the definition. You got f prime of x is 1 over 2 radical x. Over here, you got f prime of x is 1 over 2x. So this is the cheap method. It's called the car rule. You'll learn about it a little bit later on. Good luck with your homework and or quiz. Thanks, guys. Bye.